RDBMS. But if you keep on using RDBMS, you will have a big problem. But why? Because let's say on that first day of the month or 15th day of the month, or for every quarter or for every semi-annual, you will see a huge data flow will be there from these systems to a data lake. So if someone asks for a daily report, you can do it out. But if someone asking on analytics, you need a good historical data. So you will be collecting the data from a different systems. You will going to have a good historical data. Okay, you need a huge volume of data. So it's not one day data, it should be a more. When you can perform some analytics. So whenever I say analytics, you will going to come two things. You have to explain the past. You have to explain the past, then only you can predict the future. You have to explain in detailed way what happened in the past, and then you have to predict the future. Understand, right? When I say analytics, you will have two terms. One is what you have to explain the past nicely, then you have to predict the future. If you won't explain the past properly, you cannot predict any future details. Understanding, right? So when you, how do you explain the past in detail when you have a good historical data? If you use data warehouse, any other ETL tools, storing the data for long days, let's say for last 2 months data, I can't store it in the warehouse. Why? Because warehouse is a costly. If you want to store the data in that machines, it will become a costly. So that's what I would like to address right now. How are frameworks? So yesterday I spoke like we don't going to use some frameworks which comes with a code locality. When we want to process a big data, we have to go for a distributed models. When you go for a distributed models, what are the challenges you have? How do you process the data? Everything we will see today. So let's take one scenario. There is a manager for this data lake team. There is a manager for a customer care team. Okay, so what they did, right? They have created one SLA like 4 hours. For whenever you got the data from all the systems, within the 4 hours, it has to generate a report. But you know, as due to the huge feed, you are getting 1 terabyte of data for every first day of the month. So for every first day of the month, you are taking much time. Your SLA is 4 hours, but you are using RDBMS. It is taking 2 days to process the data, and after 2 days, you are giving out the report to the customer care, which is going to be a huge impact on the business. So that report contains some interesting behavior. By using warehousing also, you can do analytics. I'm not telling that you can't do analytics by using RDBMS. You can, but thing is that you are taking lot of time. As it is a sequential processing, it will take lot of time. Now this manager will going to get a question, why can't we process the data faster? So they will go with a manual approach. How do they process the data faster, right? They understand when they stored the data in a single location, it is taking lot of time to process the data sequentially. So instead, what they would like to do, right? They would like to go with something like they have created 4 different servers. See how they are solving a big data problem without using any tool. Why you have to use a tool? I mean, so why you have to go for a framework? That's what I'm explaining here. So they have 1 terabyte of data. The very first step, what they are doing, right? They will divide the 1 terabyte of data and distribute the data to 4 servers. So what will happen? That 1 terabyte of data will be divided and will be placed as 250 GB data in this machine, 250 GB data in this machine, 250 GB data. So they are manually dividing it. Okay, so once you have the data in that warehouse or data lake, they used to keep the data into 4 different servers. Usually a program used to run, right? A program used to run. So they have divided the data and distributed the data. First, there are two steps. When I say distributing, first thing you have to do is dividing. You manually divided the data. You understand, okay, I have 4 machines. So 1 terabyte by 4, you will going to get some size. And in the similar way, you will going to put down the data into that 4 different servers. I'm telling you, this is a manual approach, and we will see the challenges with the manual approach. There, we need a framework. How would it solve? We will see. As we know that if the data was stored in a single machine, we cannot really process it out faster. So, in order to overcome that issues, what you are doing, you are just going to placing the data into a 4 different servers. Okay, the second step, what you do manually, you are doing, guys, you are doing manually. You will copy the program to all the data locations, means to all servers. So second step, you will copy the program to that server. You will copy the program, you are doing manually. And then what you will do, you will just going to start the program. When you start the program, how much time it take, the same time this one also will take, this one also will take, this one also will take. Earlier, as you are doing sequential processing, it takes 2 days to process, it will complete within half day. So 250 GB data will complete within 12 hours. So then at the same time, you will going to start running this one also, the entire data will be completed within a 12 hours. Agree, right? You are doing it manually. I'm telling you, I will going to tell you the challenges with this approach as well. Every kid know, if I do it sequentially, it takes a lot of time, but if I do for a parallel processing, it will complete faster. But even every kid knows, right? But why not a lot of company has not utilized it till now? I will tell you the challenges. If they do like this, what is the big problems? I will see. I will tell you. And the third step is what you have to combine the output. Because to a customer care representative, you should not give a report like 4 files. You have to combine all 4 as a single file, and you have to give it out to the customer care representative. Okay, so in this one again, you have to overcome, let's say, network issues also, because you are building a network right now. You are building a network, so yes, you will have a network issues. Earlier the data is in a single machine, you don't see any network issues, but here your data got distributed into a 4 machines and you have a network issues as well. Okay, fine. This is how you will going to solve your big data. If someone asks you tomorrow, hey, it is taking 12 hours, right? Can you complete it by 6 hours? So your manager will ask, hey, thanks Srinivas, you have done a great job. You have saved 1.5 business working hours. So can you make it to 6 hours? Yes, he will say. Why? Because see, this approach is what? Horizontal scalable. So this is just like, you know, in your project, manager and resources are there, right? If you want, if your project work is overloaded, your manager will hire a new person. When he hire, he won't going to give a holiday to the existing resources, right? They will be working. You bring him and you add it to a project. So you are increasing the capacity of the project horizontally. So that is what your parallel processing thing. This is what horizontal scalable. But if you are using RDBMS, you have to do vertical scalable. You have to shut down the database and you have to go to maintenance. But if you go for a distributed model, it's not like that. You have to increase without touching the existing infrastructure. Add a new machine. That's it. But whereas you comes to that traditional database or warehouse things, you have to do a vertical scalable. That's what really a big problem. You will see some downtime here. But when it comes to this Hadoop related, I mean to say this distributed processing ways, you don't going to see any vertical scalable. You will going to see horizontal scalable. If someone asks you 6 hours, yes, you will going to maintain another 4 more machines, and you will divide the data as 125 MB, and it completes within 6 hours. Is it clear, right? You all understand what is big data, what are the big data problems, and how do you solve that big data problems manually. Okay, so here let's see the challenges. You understand, everyone? You can use chat box, guys. Is it clear, right? So here the challenges are this one, the very big challenges here. That is the reason why a lot of companies have not used this one till now. This is a very good idea, right? Hey, what's a good idea? Every day our company batch is taking 10 hours or sometimes 20 hours. So if I use this approach, it will be a very faster. Yes, of course. But you know why your company won't allow you to use? That's what the challenge is here. So let's see the challenges. So here the challenges will be, first thing, you have to manually divide the data and distribute. So every day you have to divide the data manually. You are dividing it manually. It takes a lot of time because you have to find out the size of the file and then you have to divide it. And the next one is what? You are manually copying. So manually copying means someone, you have to, let's say you have 10 machines, but you have placed the data into 4 machines. Then you have to know where the data was stored. Oh, 4 machines. There you have to copy. That is also manual thing. The very important thing is, right, all 4, see, your company is dying to maintain a very high-end machine. You are asking 8 high-end machines. Let's see how much costly it is. Too costly. Earlier, we maintained only 1 server. But here, for parallel processing, you are asking to go with the costly things. This is not going to acceptable by any company, because yeah, distributed processing is a good idea, but this is not going to be accepted if you're going to use a high-end machines. Is it clear, right, everyone? This is the reason why a lot of companies won't opt to process the data in a distributed fashion. So that is the reason no companies wants to process a huge data and get some insights. Got the point, right? Because it's a costly. Processing a huge data becomes costly if you want to go within a distributed model. In this case, you need some framework which can run instead of servers. So you are using servers, right? So in this case, this is costly. Even if you use warehouse or any approach, this becomes costly. So in this case, you need one framework which can divide the data and process the data in a distributed manner at a cheaper rate. So when I say a cheaper, what do you mean, right? Instead of using a server, I will use a commodity hardware, a very simple laptops or a simple hard disks. Yeah, what is your question? I understand, sir. If I use a commodity hardware, there is a problem of data loss. Instead of using high-end machines, if I come with a very cheaper machines, there is a chance that one of the machine may lost due to some network issues. Why in our companies servers will be, in our companies we will maintain a servers with high-end configuration to available every time. Why we are going with the servers 20 cores? Why can't we go with a 1 core or 2 cores? Why we go with a 1 terabyte RAM? Why can't we go with 8 GB RAM or 10 GB RAM? Why? Because why we are maintaining a high servers? Because to be available every time, you should not get any problem. But here, if you want to process the data in a distributed fashion, earlier if you use a high-end servers, it is costly. But now people are telling, instead of using a high-end servers, use a cheaper machines. So you should have a framework which can handle this data losses. You all understanding, right? See, Right now you are doing all these things manually. Now you need a framework which can do these things automatically to you. Will your warehouse will do that? No. You all understand, right? So the existing infrastructure or the existing frameworks won't try to solve this one. Even there are some tools which can do this, but they are costly. You need some tool which can process the data at a cheaper cost. So that framework is called Hadoop. Is it clear, right, everyone? You all understanding? I'm just comparing with all other tools. See, you already have Hibernate, Struts, .NET, PHP, lot of much stuffs are there, but they don't come with a data locality concept, and they really don't come with the concepts like dividing the data and processing the data in a distributed manner. And all those from, see, Java is a open source, but it is costly because you have to deploy it in a high-end server. But right now the framework which we going to talk is open source, and it is a cheaper because we can deploy it on a very low-end infrastructure where you no need to spend a lot of money. As this framework came to the market, even small company wants to process a big data because there is no cost involved here. You all understanding, guys? That is what you have to understand. Don't directly jump into the framework. If someone asks you why you are learning Hadoop when I have something like Hibernate or some other framework, you should differentiate it. Okay, I already have a warehouse. I can perform analytics there. What is the drawbacks with the warehouse systems, and what are the advantages with this distributed models like Hadoop? You have to explain. You should be in that position. Is that clear? Any question till now, guys? Use chat box, guys, for your question. Then I can read it out. Everyone can understand. Okay, good, guys.
Hello, hi.
Yeah.
So you said it's like 1 terabyte of data on a data warehouse, and you're saying that the data warehouse systems are taking longer time to process this 1 terabyte of data. But we're using this Hadoop framework. It's going to be much more faster. And one example you gave was like you're going to split it as 250 GB into 4 systems, and you're going to use that combined processing to do it. And then the disadvantages with that is that you'll have to know how to split the data manually every day.
Yeah.
So how does, I mean, 1 terabyte data is being processed by a data warehouse system. It's having specific hardware, and Hadoop is also going to run on the same kind of hardware, right? You said it's possible to run this on even a lower end kind of a system there. So lower end kind of system means it's going to have less computational power.
Yeah. It
Hadoop, which is running on a lower end system.
It have a less computation power, and it have a very less data, right? As you distributed the data, a single machine won't process all the data, right? It will process only subset of the data.
Yes.
Okay, so you don't need much computation power as like warehouse needed. Here you are distributing the data to multiple peoples, and multiple peoples will process the data parallelly and compute the result faster.
But in the conventional system, you have to split the files using manual method. So using Hadoop, are you saying that this will be an automated way of splitting these?
Everything will be an automatic. You just mention the size. That's it. It will only divide it out automatically. We have a flexibility to define the size as well.
Okay. Okay. Thanks.
Okay. So that's what. Look at this here. If you use a network file system, let's say it's a file system. If you place one file, automatically that network file system will place the data in a single location. But if I use some Hadoop file system, Hadoop has its own file system, like distributed file system, you have to mention what is the size. Automatically that will only divide the data into small sizes, and it distributes into multiple machines. Okay, fine. So let's see here. Right now, that problem, you have a challenges of processing the big data will be solved by your one solution called Hadoop. Okay, look at this, guys. Now you understand the problem. That is my agenda. Understand the problem. Now let's see the solution. So you understand the problems are like you have to manually divide the data, you have to copy the program there, you have to combine it, you have to handle network issues, you have to use a very commodity machines, and all these things will be given by a single framework called Hadoop. Okay, Hadoop has two things: storage and processing. So the storage is not like a traditional storage. Okay, so we will go into storage means we will talk right now file system here. So this file system is not like earlier file systems. Okay, this file system is not like a earlier file systems. You have a network file system which stores the data here, but here you need a file system which will divide the data automatically. That is called Hadoop distributed file system. So you really don't worry about dividing and distributing the data. The framework will going to take care about that right now. Just try to place the data by using Hadoop. So then it uses a file system called HDFS, which will divide the data and distribute the data across the machines that you have in the network. Okay, understand, right? So Hadoop is, okay, Hadoop will not going to work on a single machine. Hadoop needed some multiple machines. So that is what called, you can call it out as a cluster actually. So when I say Hadoop, you have two things. One is like storage and other one is called processing. Storage problem will be solved by using its own file system called HDFS, and you have a processing part called something called, you want to, like, you don't worry about dividing and storage the data, and you don't worry about combining. The framework like a file system itself will take care about dividing the data. So your file system will divide the data into small parts. Actually you have to specify the small part. Usually the default size that framework will follow is 64 MB for Hadoop 1.0. For Hadoop 2.0 it is 128 MB default. You can change this. I can change this to let's say you have 20 machines, so you can say that your data by 20, you can give out the size of the file, no problem. If you don't give, the framework will do divided the data manually by defaultly like this: 64 MB, 128 MB, and like this. I'll tell you why this 64 MB, why not 200, why not 300. I will talk about all these things. So you don't worry about a data storage part. It will be taken care by a file system called Hadoop distributed file system, and there is something called processing part. So you can't use Java or PHP or any other processing framework. Okay, so if you going to place the data by using Hadoop distributed file system, the data will be divided and it distributes into a multiple machines. So this is okay. This is for the storage, but how do you process the data? So when you write a program, that program should communicate with HDFS, and it should know that where the data got distributed, there the program has to copy. So you need a framework which talks with the file system and get the locations where the data got distributed. There the program has to copy it automatically. That's what called data locality. That framework that is given, that is the heart of Hadoop, that is called MapReduce. So we going to have that storage part and the processing part as a MapReduce. Understand, right? Storage is HDFS and processing is what? MapReduce. So Hadoop not going to work on a single machine, guys. Hadoop is a network one, which means that, look at this, every machine is called node. Okay, every machine is called a node. So these are commodity hardwares. Your Hadoop framework comes with a replications. I will talk everything in HDFS. Okay, your Hadoop, what it will say that even if you use a very commodity node, if you lost this node, don't worry, the data got replicated in the other node. Okay, Hadoop framework will take care about replications. If one, let's take manager and resources. If an employee is lost, do you think if one employee is absent for the day, will the work will stop? No, there will be a backup for that employee. In the similar way, that's what the manager will do. In the similar way, the file system will take care about that concept right now. The file system, if any machine lost, okay, Rekha, these machines are Commodity machines. Commodity machines means very low performance. I mean to say not performance here, low hardware. We don't going to use earlier in the last example I have mentioned, those are all costly machines. Those are all with high-end servers. They are called servers. You understand the differences between servers and commodity machines. Servers are very high-end machines. Okay, you will have multi-cores like 64 cores, like that. You have very high-end configurations. That is the reason companies, oh, we can't maintain that much money, we can't spend that much money to process that huge data. Instead, they used to sit quiet. Even they go with multiple high-end machines. Instead, right now the framework is telling that you no need to spend a lot of money. Why you are using high-end servers? Because for data availability, at any time data should be available. For that reason only you are using, right? Then Hadoop is telling, come on, yeah, like CPU power, high-end machine, low-end machine. What is the, let's say here, let's say the same laptop containing let's say 32 GB RAM, and you have other laptop which contains 2 GB RAM, which is costly. 32 GB RAM is like a high-end machine, and this is what called as a 2 GB RAM is a low-end machine. Okay, so that's what very simple concept. Instead of buying a 132 GB RAM, it is a very easy to buy 232 16 laptops, because you know something is not existed. It's very costly, but instead that you can go with a commodity machines where you will going to get a same power. Power will be the same, but thing is that the cost will be very less. Is a clear, right, everyone? So framework is telling that I don't have any problem here. We going to provide you a commodity machines where you can process the data faster with a cheaper cost. So that commodity machine is called as a node. This collections of node is called rack. Collections of node is called a rack, everyone, node, and collections of rack is called data center, and collections of data center is called cluster. Simple terminology, a cluster is nothing but a collections of node. Understand, right? If someone asks you what is a Hadoop, Hadoop is a not a server model, it's a cluster computing engine. If someone asks where you will going to compute the data, in the cluster. When I say a cluster, a data will be in a multiple machines. So Hadoop is a framework which can going to process the data which was stored in the multiple machines. So simply Hadoop is a cluster computing engine. Okay, it's a cluster computing engine. Understand, right? So earlier all your Java and all these things are a server model. They are going to store the data and they will process the data in a single machine. But Hadoop is something which can process. Why you need more manpower here? What is manpower means? Suman, what do you mean by manpower? Everything framework is doing, right? Where man will come here? Can you please be more specific in that? What do you mean by manpower here?
To operate more machine.
To
operate the machine. Laptop.
To operate the
machine.
To operate the machine?
Yeah.
Who will? Framework will do all those things, okay? Not man.
Oh.
This is what that's what the problems that I have explained. Earlier thing is what manual things that you are doing, that will be overcome by using Hadoop right now.
Okay.
No manpower, no nothing. Everything will be like you have to install the things on a multiple machines. Everything will be done by the framework itself. We don't see anything man involved here. It's in IT. If it is a man involved, we don't see any frameworks, guys. This is all automatic. Okay. It's a framework means which do something automatic. Okay. So let's say I will tell you some history, then you'll get a clear idea about it. Okay, so let's say earlier, right? Earlier, you understand what is a Hadoop? Hadoop is a distributed parallel processing framework, or you can call it as a cluster computing engine. It's a distributed storage. It's a distributed processing. So whenever I say Hadoop, you have two things like HDFS and MapReduce. Remember this point. Okay, so Hadoop is a cluster computing engine as well. So let me give you some light. I would like to shed some light on history. So let's hear. Earlier days, people got a big data. You know, first company that got a big data problem is what? Google. Okay, because see, in 2004 or in 2000, when you use Google, when you type a keyword, it took 20 minutes to display the result. At least 20 minutes to display the result. Now, right nowadays, you are getting the data very fast because of using lot much SOVs and rankings and lot many things. But earlier days, it took lot much time. DC stands for data center. Okay, fine. So you want to see what is meant by data center? You can type it out in Google, a simple part. So this is how a data center looks like. Okay, so this is like a data centers. So this is like, you know, collections of nodes, and this is called rack. Okay, understand, this is like a this is, you can going to see that the data will be distributed across this multiple commodity hardwares. Okay, so now let's hear. Any big data problems, any data related issues, Google has to come across. So what that Google thought, like, okay, we have a big data problems, how do we solve it? So very first time Google has understand that we should not process the data by storing it in a single location. So Google has created very first file distributed system called Google file system. What Google file system used to do, right? Yes, this file system used to divide the data into multiple parts and divided and stored in a high-end machines. So Google stored the data in a high-end server. So Google can spend lot of money to maintain a high-end machines. Why? Because they are affordable, because they have huge business, so they can spend a huge data part on that. Understand, right? So Google file system will take some data and distributes into high-end machines. Okay, and Google only has created a processing framework called MapReduce. So this one used to communicate with GFS, and it used to process the data. So very first time in 2004, Google has given a white paper presentations on this. We solved big data problems, but it is costly. Google only said that, hey, we solve this big data problem in a distributed fashion. So we have created a file system and we have created a processing framework. So at the same time, there is a guy called Duckity. He is our founder of Hadoop. He is still alive, working with Cloudera. Okay, this guy is called the founder of Hadoop. Duckity have a similar project like Google. That project name is called Nudge. It's a search engine only. So he want to implement the same concepts what Google is doing to his project. But thing is that Duckity cannot afford of spending high-end machines, right? So what he did, right? This is not going to work anymore. So he has created, same as GFS, he has created a new file system called Nudge distributed file system. What he was telling that, hey, instead of using a high-end machines, you can use low-end machines. Then a lot of people will get a question. If I use a low-end machine, anytime data may lost. No problem, my file system will take care about the data losses. If you lose the data here, the data will exist here. We have a replications. Okay, you have your file system, you call data mirroring, you do it manually. But here the file system is doing automatically. He's telling that you can use a low-end hardwares. It's a very cheaper, okay, where you can process the data faster than the earlier things. You will use same MapReduce only. Then it was the file system is called Nudge distributed file system. So he solved the big data problem at a cheaper cost. So what his observations and everything was cleanly observed by a company called Yahoo. They recruited Duckity. They recruited Duckity, and they has created a they have given a team to him. And in 2008, they released the first version of Hadoop. So if someone asks you What is Hadoop? Hadoop former name is called Nutch. So he renamed that project to Hadoop and he released, and he just changed it out. Instead of NDFS, he called it as a Nutch distributed Hadoop file system and MapReduce. Is that clear, right? So Hadoop is a distributed cluster computing engine which was created by Yahoo, and now they donated to Apache. It's a open source. So when I say Hadoop, you see storage and you see processing. Is it clear, right, everyone? So Hadoop is a solution for a big data problem. Not only Hadoop, there are lot many frameworks which can process it in a distributed model. They have lot many cluster computing engines, but Hadoop is the best one. Why? Because it's a cheaper. What is the reason to make it open source means what? You know why Geo gave free for everyone? Publicity that everyone will come to know. That's a basic marketing strategy that what is the reason to make a open source means it's irrelevant question. Okay, here, okay, that's their deal to make it. Lot many open sources are there. Why they made it open source? We don't need, right? Okay, we'll just use it out. Okay, fine. So let's say here right now Hadoop. Okay, Hadoop is a solution for your big data problems. It have a storage, it have a processing part. Okay, fine. So this is Hadoop. This Hadoop we're going to talk it in our classes. So as I spoke, we divide our entire course into 5 parts. That is called injection, and the other one is called storage, and the other one is called processing, and the other one is called cluster management, and the other one is called integrations. So let's say you have some data. I'll explain it like it in a project, and I will explain that in detail. Now look at this here. Okay, so let's say here. Okay, fine. So let's say here you have a Hadoop. Hadoop means you have a multiple machines. Look at this. What is that storage that we have it in Hadoop? That is called HDFS, which means that the data getting stored in the multiple machines. So look at this here. So I said you will, the storage part that we use is what? HDFS. So you have a multiple machines, everyone. You have a multiple machines, and how data will be stored into this multiple machines? You have to use HDFS to place the data into Hadoop cluster. Understand, right? Then the data will be distributed. You have to place by using this file system. So the storage part is what? HDFS. Now the question comes like this. The question is, how do you inject the data into Hadoop? Hadoop is a file system. Hadoop is a batch. Remember, Hadoop is a batch system. It's a file system. You can't inject the data from a web application, right? You cannot insert the data into Hadoop by an application. It's a batch. It's a file system. You cannot attach a file system to a web application. Then how do you bring out the data? That's what, like we will see how do you inject the data. So let's say you have some web server logs. You know, right? What is a web server logs? So how do you inject these web server logs into Hadoop? Hadoop should need to get the data from the external world. No application won't inject the data into Hadoop, like warehouse. No data won't be injected into warehouse. It has to come from a database only. As Hadoop can process unstructured data as well, it can bring out the data from a web server logs. So the data sources. So usually Hadoop will going to get the data from a two means. So it can get from a application server or it can get from database server. So when you have an application server like you call web server logs, how do you inject the data into Hadoop? So there is a tool which is injecting the data into Hadoop. If it is unstructured data or web logs, the tool is called Flume. A Flume is a real-time injection tool. When something is happening in the application server, that one will inject the data into the Hadoop cluster then and there. This is called a real time. When something happens in the application server, This is called event based. You can call it as event based. When event happen, then and there it will inject the data into Hadoop and it distributes the data into the multiple machines. Is that clear, right? So the framework which injects the data into Hadoop is one of the framework is called Flume, which is what kind of data you want to inject. Is it event based? Then you have to go for a Flume. What is Flume? How to integrate it with different things, like you can integrate, let's say you have an application server. So application server will be throwing the data at a port number. So let's say it can throw to a port number, or it can write to a folder. Anything happens in the application server side, automatically Flume has to recognize it and it has to push the data into the Hadoop cluster. Remember, from an application you can't insert the data directly into the Hadoop cluster. Remember that point. Okay, so Flume.
Ankur, so Flume is like an intermediate, right, to inject the data?
Yes, it's like, you know, injector. You can call it as base, which can inject the data from an application to the cluster.
From external to the cluster. So
Yes.
what language is this Flume coded on? Like, is it like?
It has its own language. It's a pure XML. It's a configuration file. It's not a framework. I mean, it's not a language actually.
Okay. Thank you.
Okay, it's like a configuration files. All frameworks has its own languages here. When we need language, when we want to process it out. The remainings are simple SQL commands. All these are out.
Okay.
Okay. The next. Okay, so when you want to use some like, so if you want to bring out the data from the web server logs, you will use Flume. And that's what streaming data from web servers, we will use Flume to dump the data into the Hadoop cluster. Then what is the another data source? Databases. Okay, databases are someone don't wants to change its architecture. They want to go with the directly like this. They have a warehouse and they would like to dump the data from warehouse into the Hadoop cluster, because earlier people used to do processing at a warehouse only, but we don't want to process the data right now warehouse. So bring out the data from the warehouse into the Hadoop cluster, or bring out the data from the databases to the Hadoop cluster. So there you have to use a tool which can inject the data from the databases into the Hadoop cluster, that is called SQL to Hadoop, which is called Scoop. SQL to Hadoop. It was given by Flume and Scoop, given by Cloudera, and they have donated to Apache. Right now they are open source. They are under the umbrella of Apache only. But Flume and Scoop, both given by a company called Cloudera. And the Scoop can also inject the data. So if it is in a traditional database, if it is a structured data, or if it is in a database server, if you want to bring it out, okay, because this is not event based, this is what called trigger based. You have to run, and that will inject the data into Hadoop cluster. So if you want to bring the data from an external world into Hadoop, because you know it's a file system, you cannot attach an application to that file system. So you have to bring the data from the outside of the world, means from the application. See, if you are using Hadoop, let's say here, guys, everyone, in your company, you already have something called application layer. You have something called business layer. You have something called database layer. Now you will going to create a new layer called analytics. This is a new layer. You are giving it out to your client, saying that, hey, you can get some insights of the data. Okay, so then with that insights, make a good decision. This is what you are giving to your client. So usually you have an application like this. Don't touch this one. Hadoop framework is very successful. Why? Because it's a new layer added to the existing project. So you no need to touch the existing infrastructure as it is. Keep it like this. From there, inject the data into the cluster. Don't change application server to inject the data directly into Hadoop. No worry. There is a tool called Flume who will observe that and brings the data. There is a tool called Scoop. Why you using these tools? You might have a question, sir. I have a traditional way of ETL tools which can inject the data, SQL loader and all these things. See guys, they download the data sequentially, but all this data will be configured to inject with HDFS. If you use SQL loader and all these things, they are not integrated with HDFS. If I use SQL loader, it will put the data in a single file system. But here, the storage, the distributed part is what? Hadoop. So they have these guys only can understand what is Hadoop. If you use any other tools, they cannot understand Hadoop things. They will store the data in a single location. That's the reason we have a special tools which injects the data into Hadoop cluster. If it is of course, when I say data, you will have application server or database. These two things only you will see. If it is an IoT data also, it's an application data only, and that will be integrated by Flume or Kafka, which injects the data in the real time. Scoop is just like, for every 6 hours, we will going to bring out the data from the database into the Hadoop cluster. So you will have a batch. So let's say yesterday I showed you a Book My Show. Do you remember? Book My Show only, right? I showed you. Did I show you Book My Show? Like real time things. Okay, let's hear. If I open any website, if you perform something, it won't get updated then and there. It will be updated later on. So for every 6 hours, it collects all the data and it pushes into the Hadoop cluster. Okay, this is like a trigger based. You have to run. It's not like event based. Like you have to configure. You have to write some cron jobs or some schedulers like that. Okay, so these are the two injectors which injects the data into the Hadoop cluster. You all understanding? It's not a web application. It's not a database. Hadoop is not database. First thing, understand. Hadoop is a pure file system. You got the point, right? So this is how you will going to bring out the data from outside of the world into Hadoop. Clear? So this is a file system, but I want something called database as well. So if you want to maintain a database on top of Hadoop, there is a database that is called HBase, which was created by Facebook and donated to Apache right now. HBase is database on top of Hadoop. It is not part of Hadoop, guys. Remember, you know Oracle, right? Oracle is what? It is a database on a file system. Indexed network file system is called Oracle. You agree? File system is different, Oracle is different. In the similar way, your file system is HDFS. Now you want a database on top of that. That is called HBase. It's a NoSQL database. It's not a SQL database. You don't have any structure, any validations, nothing. We will talk about that one as well. Okay. So you will see a NoSQL database. HBase is a database on top of Hadoop, guys. HBase is not a part of Hadoop. It's a top of Hadoop. Flume and Scoop, these are all on top of Hadoop. They are not part of Hadoop. Hadoop means HDFS and MapReduce only. Hadoop means these two things only. Is it clear, right? So I'll show you integration of Flume, bringing that application server data into Hadoop as well as HBase, integrating the RDBMS data into Hadoop as well as HBase. I'll show you this both integrations as well. You all understanding, right, guys? So injection part and a storage part. Now let's talk about a processing part. The chart. Okay, so now you got the data. Now you have to process, or you want to perform some analytics. So look at this here. So to process the data, we have an underlying processing framework that is called MapReduce. Okay. Thanks. Okay, thanks, Praveen. And Rajendra Bhattu. Instead of HBase, can we use MongoDB or Cassandra? Can Hadoop and MongoDB use by combine in real time? Yeah. So this is a good question actually. Okay. Okay. So look at this here. Yeah, I have a question like instead of HBase, you can use anything, but look at this here. Why we are MongoDB and Cassandra has their its own file system, Rajendra. But HBase is having a file system of Hadoop. MongoDB we can use without Hadoop. Got the point? MongoDB no need Hadoop, right? MongoDB can work it has its own file system. Cassandra is what it has its own file system. Instead, you can call Cassandra and Hadoop are competitors. You don't get messed up with someone like Hadoop integrating with Cassandra. Guys, I have a simple question. Why you will integrate Cassandra and Hadoop? Both are storage, guys. Why do you integrate them? Understand that, right? So that's what HBase uses Hadoop as its file system. Cassandra has its own file system. MongoDB has its own file system. There are 125 plus NoSQL databases, Rajendra. But why we choose HBase only? Because HBase has its own file system called Hadoop. That's the reason we are learning Hadoop. That's the reason we are learning HBase. Got the point, right, Rajendra? Okay, fine. Okay, look at this here. Now the next one is what we need, processing part, that is called MapReduce. So right now let's go with this one. So the MapReduce, see guys, I will ask very simple question, you try to answer. Oh, there is a car. Car is a framework, agree? Car is a framework. But how to drive a car? Car is a framework. How to drive a car is an API, or you can call language. So let's say here, who prepared car? Let's say mechanic. Okay, who prepared car? Mechanic. So if I say, okay, sure. Okay, so let's say you have a car, and who prepared the car? Mechanic. If I say only mechanic should drive car, then is it correct? Hey, mechanic only prepared car, so mechanics only should drive car, which is an impossible in the world. You agree with me? People who don't have any mechanical skills also can drive a car. That is the reason why car become popular. If I say people who prepared car, they only has to drive, means it's not going to work. In the similar way, the MapReduce framework was written in Java language. If I say people who know Java only should use MapReduce, then no one will use it. You agree with me? Yeah, if you are a mechanic and if you have a driving skills, it's an advantage, but it's not mandatory. You got the point, right? In the similar way, if you have a Java skills and if you are learning Hadoop, it's an advantage, but it's not mandatory. You all agree with my point? If only Java is the language that you use to communicate with Hadoop, no Hadoop. Now till we don't talk about Hadoop right now. Because Hadoop, you can use any language, but underlying processing framework is called MapReduce, which will communicate with HDFS and copy the program there and process the data. Is it clear, right? You all agree with this point? So as MapReduce is written in Java, it's very hard to write the code in Java, because if I want to find out the average age of the employees whose salary is 50,000, you have to write big Java code. You need literally lot much dependencies added to your project. You have to deploy lot much maintenance work is there. So in order to overcome that MapReduce related things, your Facebook has created a framework called Hive. Hive means SQL on Hadoop. No need to write a Java code. Use SQL code. That SQL code will convert. Look at this here. Hive, what it will do? It will convert the SQL into a Java, I mean to say MapReduce code, and that will work on HDFS. You no need to write a Java code. Instead, write a Hive. Hive is an SQL on top of Hadoop. It was created by Facebook and donated to Apache right now. It is under the open source. So Hive can be used as a processing framework here. So here, when I write an SQL query, look at this here. It will launch as a MapReduce job and process your distributed file system. Literally, you don't need to write a Java code. Your framework called Hive will going to process the data by using SQL. Is it clear, right? So you will have a different tables, and you will process the data and you will update back to the RDBMS again by using Scoop. Is it clear, right, everyone? So that other processing tool. So if someone asks Hive, don't call Hive as a database. It is also processing framework, but you will use SQL on top of Hadoop instead of using Java. So that is what called Hive. Hive is only used for structured processing. For unstructured processing, there is a framework called Pig. This is also processing framework, but this is also like SQL only, but it doesn't going to have any structure. It can process unstructured data. Why they named pig, right? Because pig eats everything. Pig cannot differentiate the bad and good, right? So that's the reason they named it as a pig. Actually, pig framework was given by Yahoo and donated to Apache right now. Okay, it was initially given by Yahoo only. See, most of your jobs, guys, will be on these two. Any company you go, they will ask these two. Out of 100%, 80% of jobs will be on this rather than on the Java code. You all understanding, right? Okay, fine. I'll just take another 5 minutes, guys. I don't take much of your time. Let's hear. It's a weekend, I know that. Okay, let's hear. Cluster management. So for a cluster management, if you have, look at this here. If you have multiple resources, means there should be one guy who has to share the resources of the cluster across your jobs. Let's say you have multiple jobs. Let's say 10 jobs are there. So each job, how much percentage of the cluster you have to needed will be decided by one cluster management tool that is called Yarn. Yarn means yet another resource negotiator. Okay, this is like a Yarn is what? Let's say who will going to be a resource negotiator for your project? Your manager. Agree? Manager knows how much percentage of the resources has to be utilized for the particular job. Let's say a client will come and the client will ask manager to perform some task. Then a manager will say, oh, manager, okay, fine. Okay. Oh, fine, sure. I'll go on. Thank you. So like a cluster management, I will tell you very simple thing. Let's say your manager is there. You have 10 people in your project. 5 clients came and asked your manager, I want to perform a task by these 10 people. So you have 5 clients. Look at this here. You take this PPT. And what is a cluster management? I'm telling you. Let's say you have 10 people under a single manager. This is a single manager. So you have 3 clients. Let's say 3 clients ask manager to perform some task it in a distributed model. Why? Because you have 10 resources. He knows that he will only divide the data and gives to 10 people. They will process the data. But you have 3 jobs: job 1, job 2, job 3. So right now, he has to manage the resources of the cluster, right? He has to manage the resources of the cluster. Okay, well, how do he manages the resources of the cluster, right? It's like this. Look at this right now. So he will going to say that, okay, hey, one person, you allocate your 2 hours to job 1, 3 hours to job 2, like that he will going to allocate. So who is managing that resources of your project? Manager. Like that. When you have multiple machines in the cluster, multiple jobs will be submitted. Agree, right? So when a multiple jobs submitted, how much a job need, how much percentage of the cluster is decided by some cluster management tool that is called Yarn. Yarn will going to allocate the resources, and in that particular machine your MapReduce code will going to run. We will talk in detail all these things. Just I'm giving a introduction part here. Okay, so that is what a cluster management. I don't talk anything about integrations. When you understand all these things, you will understand about integrations like hcatlog. It's an integrated tool like Hive, and anyone will can communicate by sharing the structure by using hcatlog. Zookeeper is just like a data discovery tool, and also you have something called job schedulers like Uji. So there are some integration parts, and I will show you 2 projects like clickstream analytics and sentimental analytics. Okay, so you can put down these projects in your resume as well. This is going to help you a lot. I'm telling you, by completing, if you attend these classes without any file, I'm telling you, you can easily clear interviews. Guys, I have taken much proxies. I have placed more than 200 people. So I know what questions people will ask and everything. If you attend these classes without any file, I have a gut feeling that you can easily clear the interviews. Okay, see here, this training includes you. If you attend the classes without any breaks, you can easily clear Cloudera Hadoop developer certification. You don't need extra training for it. This training includes all that parts, and you can going to put easily 3+ years on Hadoop. Okay, and I will be sharing you some resumes where you can go into put you. I will give you some sample resumes. You prepare your resume according to that and forward to me. I will do some corrections and I will going to let you know. The goal of this entire game is you have to remember me, guys. Okay, you see, this is not a money game or this is not something. Finally, you should be placed and you should feel that you are learning something new every day. That is the goal, not to complete the course faster. Okay, understand that? Goal is you have to feel refresh every day. Guys, Hadoop is everyday new thing. You, even if you have 20 years experience in IT, everything is new to you. Remember, even your 1 year's experience also, everything will be new. Functionality only helps you when you have a good experience, that's it. But technical thing, everything is new. Okay guys, is it clear? You understand what we are going to talk? So the very first thing that I'll get started is what? Storage. So I'll from Monday onwards, the classes will start at 7 a.m. IST and I will start with storage. First we will talk about architecture in detail, then we will get into the practical. Okay guys, so we will meet again on Monday 7 a.m. IST. These are the things that we discuss in our classes in the course. Okay, any questions?
Hi, Ankur. Hello, Ankur.
Ankur, who is Ankur?
Sorry, your name I didn't.
I'm hearing uncle. I'm not uncle. Okay. My name is Srinivas.
Oh, sorry, Srinivas. Srinivas, but I was wondering, like, thanks for all this wonderful introduction to Hadoop. I mean, nobody could have done this better. And with the end of this session, I have a few questions. Like, after your course, what kind of Hadoop profiles can we be applying jobs for? Like Hadoop administrators or Hadoop developers? What kind of profile do you think we can be fitting into? I mean, would we be creating the HDFS right from scratch, and then would we be programming some stuff? And you had 2 projects as well, so I'm sure we cover the developer aspect, but will we cover the administrator aspect as well for this?
Yes, that's a very good question. So when I say a big data, you will have a lot many roles. Okay,
so Hadoop admin also we can apply, and Hadoop developer also we can apply.
By this one, you can apply both Hadoop admin, Hadoop developer.
Okay, thank you.
Very first 1.5 week, I will talk about admin only. So every part when I started, for example, if I start HBase, I will tell you what are the administrator roles in HBase. If I start Hive, what are the administrator roles in Hive? If I start Pig, what are the administrator role in Pig? So everything I will going to cover. It's like, you know, I don't put headings like admin and a developer, but I will going to tell you in Pig what are the roles of administrator, developer. Let's say Hive, administrator, developer. Then you will going to get a clear clarity. So
So will we create an HBase database? Will we create an HDFS file system?
Everything we will do. Everything in a class, everything is practical.
Okay.
Okay.
Is it available off the internet, all this software, or will you share it with us?
I will share you everything. I have a VM and I will share you that VM, and I will going to do that. I will just going to show you how to install and all these things. Yes, someone is asking that, can I learn Spark? Yes, guys, Hadoop is bacha thing when compared to Spark. I very good in a Spark things, because Spark is what the latest hot cake. You can join Spark classes as well. I took demo yesterday and today. You please collect the recording sessions from the management I only delivered from 6 a.m. to 7 a.m. You please take the recordings and have a look on that, what is Spark and everything. If you like, you can join. Okay, but you will going to see that Spark also very good, but you can learn both the things at the same time, Spark and Hadoop. Why? Because I am teaching both, so I know how to balance these two things. If you are learning Hadoop from someone, Spark from someone, you have a problem if you are learning at the same time. But I am teaching both, so I know what to teach what and what to teach next. Okay, so if you're going to get that one, I think you can ask some concession as well if you're taking 2 courses at a time. Okay, so I'll read out your questions, guys. Yes, I was just getting. Yes, Rajendra, you can learn Spark as well along with this. I recommend you, not for money here, I'm recommending you to learn the 2 things at a time, because both are distributed model. You can get a more idea in detail. If you have some interest, use it out that one at the same time. Okay, you at the same time you can complete both the things. That would be very easy for you. And other question is Rajendra Battula, sorry, any advantage if you learn Spark along with this? Yes, of course. You have an advantage when you have a new framework, right? How many cluster will manage in this course? I'll show you 4 node cluster, Mahendra. Yeah, everything is coding. I will code. MapReduce, I will show you the code and I will execute. From Hive pick, everything I will code manually. Okay. Ankur will let you know if you have any weekend classes. Okay. Shravya, okay. See, guys, everyone, I want to know your basic expectations. So use my mail ID. What is your expectations? You might be feeling hard to explain right now in the class. This is my mail ID. Okay. Use this mail ID and put a subject like this: morning Hadoop batch. This is the subject. Guys, put this as a subject. Don't use any other thing, because I deliver daily 6 classes. I don't know with whom I'm talking. Okay. So I have a classroom classes and online classes. So that's the reason I'm not sure with whom I'm talking. So I need a subject like this. Don't directly talk with me, because I can't address which batch you are. So use this as a subject, morning Hadoop batch, and give your expectations. So this is what I want to gain after completing this course. So I will going to go accordingly like that. That will help you as well. Okay. So please send your queries or your expectations to this mail ID. Okay.